Good morning to all. This is Dr. Y.V.N.R. Swami, Associate Professor in the ECE department. Today I am going to teach the topic Coulombs law and electric field intensity in the subject of electromagnetic waves and transmission lines. Electromagnetic waves. So before going to learn the topic electromagnetic waves, we will know the two topics, electric field and magnetic field. First of all, electric field. If the charges are at rest position, then it will produce a one field. That field is called electric field or electrostatic field. If the charges are moving with a uniform velocity, then it will produce a field is called magnetic field. Then coming to the electromagnetic, the charges are moving with an acceleration, then it will produce a field. That field is called as electromagnetic field, or the combination of electric and magnetic field is called as electromagnetic field. Okay, so that is electromagnetic field. So now coming to our topic, Coulombs law and electric field intensity. Coulombs law. This law, it is an experimental law. This law is formulated in the year of 1785 by the Charles Augustin de Coulomb. And this law deals with the force the point charge exerts on another point charge. Coming to the statement or definition of this Coulomb's law. Now we will take 2 point charges. So these are the 2 point charges, Q1 and Q2. Okay, so Coulomb's law states that the force between 2 point charges Q1 and Q2 is along the line joining them, as well as directly proportional to the product of two charges Q1 and Q2, and inversely proportional to the square of the distance r between them. Okay, that is the Coulomb's law. So the statement of Coulomb's law is the force between these 2 point charges is along the line joining them, directly proportional to the product of the charges Q1 and Q2, and inversely proportional to the square of the distance r between them. So that is mathematically written as F is directly proportional to Q1 Q2 by R square, Q1 Q2 by R square. So that is equal to F is equal to K into Q1 Q2 by R square, where K is the proportionality constant and its value is 1 by 4 pi epsilon naught. This is the value of proportionality constant. So in this constant, epsilon naught is a permittivity of free space. Permittivity of free space. Okay. And K is equal to 1 by 4 pi epsilon naught. Its value is 9 into 10 power 9. 9 into 10 power 9 meter per farads. And here epsilon naught value is 1 by 36 pi into 10 power 9, that is equal to 8.854 into 10 power minus 12 farads per meter. Farads per meter. Okay. That is Coulombs law. What is Coulombs law? Coulombs law states that the force between 2 point charges is along the line joining them directly proportional to the product of the charges q1 and q2 and inversely proportional to the square of the distance r between them. R between them. Okay, that is the force according to Coulomb's law. Therefore, F is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. So now we have to observe in this formula, there is in this formula it having only magnitude. There is no direction. Hence, based on this formula, we will say that the above one is a scalar quantity. Scalar quantity. So the force is a scalar quantity because it has only magnitude, no direction, no direction. But we know that force is a vector quantity. Okay, so force is a vector quantity. Vector quantity should have magnitude as well as direction. But in this case, this force having only magnitude, no direction. So this is a scalar quantity. But actually, force is a vector quantity. So now we have to assign direction to this formula. Then the force is a vector quantity. Okay, now we'll see here. We are taking 2 point charges. So it is a Q1 and Q2. So now direction is from Q1 to Q2. Q1 to Q2. So Q1 is a point P of X1, Y1, Z1. And Q2 is at the Q2, the point P2 of X2, Y2, Z2. And the direction is from Q1 to Q2. That is point P1 to P2. P2. So now we will see that the distance between these 2 point charges will be represented r, and the direction is from 1 to 2. Then r12 is the distance between the 2 point charges q1 and q2. Okay, so now we will write force formula according to Coulomb's law is F suffix 1 2 equal to 1 by 4 pi epsilon naught into Q1 Q2 by R12 square into A suffix R12, where A suffix R12 is a unit vector. Unit vector. What is unit vector? Unit vector is a vector whose magnitude is unity. Whose magnitude is unity. Okay. So A suffix R12 is equal to R suffix 12 by mod of R suffix 12. It is a unit vector. Okay. So now we will find the distance between these 2 point charges. R suffix 12 is a vector, na? That is x2 minus x1 into ax plus y2 minus y1 into ay plus z2 minus z1 into az. Then mod of the vector r suffix 12 is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So it is a r12 is a vector, mod of r12 is a magnitude of that vector. Okay, so now finally f suffix 12 is equal to 1 by 4 pi epsilon naught into q1 q2 by r12 square into a suffix r12. So you can write one more way also this formula. R suffix f suffix 12 is equal to 1 by 4 pi epsilon naught into q1 q2 by r suffix 12 mod of r suffix 12 whole cube, because a suffix r12 equal to r12 by r mod of r12. Okay, so just replace this one with this unit vector. Okay, that is f12 equal to 1 by 4 pi epsilon naught into q1 q2 by r mod of r12 whole cube into r1. Okay, so finally this is the force formula according to the Coulomb's law. Coulomb's law. It is a vector having magnitude as well as direction. So this is a unit vector representing the direction. So this is only force due to 2-point charges. 2-point charges. Force due to 2-point charges. So now we will see the for n number of point charges. N number of point charges. Okay. So for n number of point charges, Q1, Q2, Qn located at R1, R2, Rn, then the resultant force F on the charge Q located at point R is vector sum of forces exerted on Q by each of the charges Q1, Q2, and so on Qn. Then the force formula due to n number of point charges is Q1 of R minus R1 by 4 pi epsilon naught mod of R minus R1 whole cube plus Q2 into R minus R2 by 4 pi epsilon naught mod of R minus R2 whole cube plus and so on Qn into R minus Rn by 4 pi epsilon naught mod of R minus Rn whole cube. So then we will write this one. F is equal to what is the common term in all these? Q by 4 pi epsilon naught is common in all these terms. Then sigma k equal to 1 to n Qk into R minus Rk by R minus mod of R minus Rk whole cube. So this is the force formula for n number of point charges. N number of point charges. And this is the force formula for 2-point charges. 2-point charges. This is the force according to Coulombs law for 2-point charges. Similarly, this is the force for n number of point charges. Force for n number of point charges. Okay, so then we'll go for electric field intensity. So initially we already discussed about electric field. Electric field. If the charges are at rest position, they will produce a field. That field is called as electric field or electrostatic field. Electrostatic field. So now we will see the electric field intensity from the force. From the force, we know that force is defined as a product of electric field intensity and charge. So from that formula, we will define the electric field intensity. What happened? Electric field intensity equal to force per unit charge. Unit charge. So now we'll see that definition. Electric field intensity. Electric field intensity. It is defined as the force per unit charge when placed in an electric field. Force per unit charge when placed in an electric field. And this electric field intensity is also called as electric field strength. Electric field strength. So then we can define electric field intensity E equal to force per unit charge. E equal to F by Q. And we know that units of force are newtons and units of charge are coulombs. Then unit of electric field intensity is newtons per coulomb or volts per meter. Volts per meter. So force is a vector, has direction as well as magnitude. Then electric field intensity also a vector, has magnitude and direction. And electric field intensity is obviously in the direction of force. Okay, so now we will find the electric field intensity due to a point charge. Due to a point charge. So see here. So here we are taking a point charge Q1 at this point. Then it will produce an electric field equally in all directions. We are taking a small charge Q1 placed at one point, then it will produce as a electric field equally in the all directions. All directions. So in this electric field, we are placing one more charge Q2. This one more charge Q2. Q2. Then electric field at point charge Q2. Q2 due to charge Q1. Electric field intensity at point charge Q2 due to point charge Q1 is given by E equal to F by Q2. E equal to F by Q2. Okay, and we know that a force due to Coulomb's law is force between these 2 points according to Coulomb's law is product of these two charges Q1, Q2 by distance between these 2 points will be represented as r. Then F is equal to Q1, Q2 by 4 pi epsilon naught r square along A suffix R12 direction, along AR direction. Then by this Q2, Q2, then Q2, Q2 will cancel, Q2, Q2 will cancel. Then obtained formula is Q1 by 4 pi epsilon naught into R square along AR12 direction. Here A suffix R12 can be written as R12 by mod R whole cube. So therefore, electric field intensity at point R due to point charge located at R dash can be written as E equal to Q by 4 pi epsilon naught R square along AR direction, that is equal to Q into R minus R dash by 4 pi epsilon naught into mod of R minus R dash whole cube. So that is the electric field intensity due to a point charge. Due to a point charge. Okay. So now electric field intensity due to point charge is Q by 4 pi epsilon naught R square along AR direction over R E equal to Q into R by 4 pi epsilon naught mod R whole cube or Q into R small r minus R dash by 4 pi epsilon naught into mod of small r minus R dash whole cube. That is the electric field intensity due to a point charge. Due to a point charge. Okay. Now we will go for n number of point charges. For n number of point charges Q1, Q2, Q3 and so on Qn located at R1, R2, R3 and so on Rn, then the electric field intensity at point R is given by E equal to Q1 into R minus R1 by 4 pi epsilon naught mod of R minus R1 whole cube plus Q2 into R minus R2 by 4 pi epsilon naught mod of R minus R2 whole cube plus and so on Qn into R minus Rn by 4 pi epsilon naught into mod of R minus Rn whole cube. R minus Rn whole cube. So this is the electric field intensity for n number of point charges located at R1, R2 and so on Rn. Now from this one, the electric field intensity is equal to, so what is the common term in all these 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught into sigma k equal to 1 to n, sigma k equal to 1 to n qk into r minus rk by mod of r minus rk whole cube, r minus rk whole cube. So this is the electric field intensity for n number of point charges. For n number of point charges. What is the electric field intensity due to a point charge? This one. E equal to Q by 4 pi epsilon naught r square along AR direction. So what is the electric field intensity due to n number of point charges? N number of point charges. E equal to 1 by 4 pi epsilon naught into sigma k equal to 1 to n q suffix k into r minus r suffix k by mod of r minus r suffix k whole cube. This is the electric field intensity for n number of point charges. N number of point charges. Okay, so I hope you people understood uh, these two topics, Coulomb's law and electric field intensity. Force from the Coulomb's law and electric field intensity. Okay, so in the next class, we will solve a good problem. Okay, one problem on this force and electric field intensity. Okay, thank you.